So good morning all. In this class, we'll discuss about interference and undercutting of gear. Okay. So just look at this sketch. So this is the first part where we have full fit of involute pair. So conjugate actions, conjugate profile, and second is full fit of involute. So again, it is a conjugate action. Now the pairs are given and common normal which is given, which is passing to the pitch point. So this, if you look at the surface, this is the working profile of involute circle, which is having constant pressure angle for the surface. Okay. And we are talking about the clearance which we are providing to avoid the undercutting of gear. Now, what is happening if suppose a second tooth profile, let's say we have another tooth profile which is engaging to this tooth surface at this location. Okay, this is a second tooth profile. Okay, now what is basically happening if this tooth surface is going below that base circle line? Okay, then it will undercut the base surface of that second gear or second gear, we can say. And this phenomena is known as undercutting of gear. Okay, and what is interference? Suppose if two gears are reaching the maximum addendum level. Suppose we have RA for pinion, RA for gear. Okay, so there will be jamming or locking of gear will going to happen, and then that part is called as interference. So to avoid this, there are different methods which is available. Either we can increase the center distance, either we can increase the pressure angle between the pairs, or either we can provide proper value of addendum for pinion and gear to avoid the interference and undercutting of the tooth surface. Okay, now just we'll discuss how to find out these uh, parameters. So just look at the values. So addendum radius we have discussed, that is O1n is the addendum radius of the gear. Okay. Suppose if the addendum radius of pinion is increased from O1n, at that point L will move to L2n. Okay. So this is the maximum value. And again, we are increasing the addendum radius. So actual addendum radius is actually O2P, and we are O2K is the distance, and we are increasing from O2K to O2n. Okay. So what is happening? This distance is further increased, and the distance is going below the beyond that base circle. Okay, so and if it is happening that, then this surface we're going to cut the base surface of second circle, base circle of second pair. Okay, so when we are further increasing that radius, then point of contact L will be moved from, will be moved on the inside of base circle of wheel and not the involute profile, so it will cut the base surface. Similarly, if you consider tip of tooth on pinion, which will undercut the tooth of wheel. Okay, so when these two surfaces are locking to each other, then it will move the base surface of, suppose if one tooth surface of pinion is reaching beyond the surface of second tooth, then definitely it will cut the base surface of second tooth, and then this phenomenon is known as undercutting. Now just look at the arrangement. So when we are talking about the jamming or locking of the gear, okay, like just we take a distance of M and N. Okay, so these M and N points are the extreme points where your gears are reaching the maximum addendum value. Actual addendum value is only up to L and only up to this K point. But if it is reaching the value up to N and M, then basically both the surface will go into undercut to each other, and there will be locking of gear or jamming of gear will be happen, and we cannot transfer the motion or power between this pair when this type of phenomena will going to happen during the mixing transaction. Okay, so that's why to avoid this interference or undercutting, we need to either increase the center distance between the pair, either we need to increase the pressure angle value, or we need to provide appropriate value of addendum radius for pinion and gear to avoid the interference or undercutting of that particular gear. Okay. Now, next part is how to avoid the interference. So just look at the data. So to avoid the interference, we have maximum length of path of approach. So it is maximum length of path of approach, that will be MP. So we have taken the maximum radius. So this MP will be R sin phi. Similarly, we have maximum length of path of process, that is Pn, which is given by capital R sin phi. So you can take Mn is equal to MP plus Pn, small r sin phi plus capital R sin phi. That is small r plus capital R into sin phi. So you can write maximum length of arc of contact, this R plus R sin phi upon cos phi. That is R plus R into tan phi. Okay. So based on this, we can calculate path of contact. Then if you have path of contact, just divide by cos phi, you will get arc of contact for this pair. Okay. Now just look at the example. Suppose we have two mating gears having value 20 and 40. Involute module is given. Let's say module is 10 mm. Pressure angle is 20 degree. The addendum on each wheel is made such that line of contact on each side of the each point has half maximum possible length, and we have to determine the addendum height for each gear wheel, and we have to calculate path of contact, arc of contact, and contact ratio. Now we can take T value, number of teeth are available 20 and 40, module is 10 mm, pressure angle is 20. So we can write R is equal to MT upon 2. Okay. So pitch circle radius is module into number of teeth upon 2. R pitch circle radius for pinion is 100 mm. Pitch circle radius for gear is 100 mm. Okay. So this we can calculate R is equal to MT upon 2 and capital R, capital M into capital T upon 2. So we get R value 100 for pitch circle is for pinion, 100 for gear, it is 200. Now what data we have? Path of approach is given, maximum path of approach is equal to half of the maximum value. So this path of approach is under root of R square minus R square cos square phi minus R sin phi equal to R sin phi by 2. So if you put all these values of RA, R cos phi and sin phi, then you get RA value 206.5 mm. Okay, so this is the addendum radius value for that pinion. So addendum radius for gear we can say 206.5. Okay. Next, addendum value, we can calculate addendum radius minus pitch circle radius 206.5 minus 200, that will be 6.5. Similarly, for path of precedence, we can calculate PL is equal to half of PN. Okay. Now, what is precedence? Small r square minus r square cos square phi minus r sin phi is equal to capital R sin phi upon n. Maximum value we are talking. So by putting all these r cos phi sin phi, we have RA value 116.2. So what will be the addendum height for smaller gear? It will be RA minus R. That is 116.2 minus 100. Okay, so it will be 6.2. 110. It will be 6.2. Okay. So path of contact will be Kp plus PL. Okay, so R plus R sin 5.2. You can put this R value and capital R value. So you get path of contact 51.3 mm. Similarly, we have arc of contact. So what will be the arc of contact? It will be path of contact upon cos phi. 51.3 upon cos 20. So this arc of contact value will be 54.6 mm. Okay. Then we have to calculate contact ratio. What is contact ratio? It will be length of path of contact upon circular pitch. So we have this 54.6 at 1 pi into m. So this contact ratio is 1.74. That will be 2 into. So in this way, we can determine the contact ratio for gear. Okay. So this is all about how to define the contact ratio for the gear. Thank you.